All right, here are solutions for our first quiz from Math 213. You're given this mess, which I just got out of your book, and told to identify each of the shapes below. For some reason, this vertex here isn't labeled. I don't know why. So I told you to call it L. Fine. So you're asked to find a square, and not just find a square, but say, oh, there's a square, I don't know, KQHI, for example, or ILCF, ILCF. Fine, those are squares. But don't just say it's a square, say it's a square because all of its sides are the same length, and all of its angles are 90 degrees, something to that effect. So square's all done, nothing to do there, but what about rectangle? Well, there's a couple different rectangles here. It looks like there's one over here. There's one out here. There's probably others, but I'm going to go ahead and talk about, I don't know, QH, DF, QH, maybe FD. I'll go in order here. Is a non-square rectangle. It's a rectangle because for 90-degree angles, but not all sides are congruent, equal length. I'm going to run out of room pretty quickly on these, I see. Okay, that's one explanation you could give. It's a rectangle because it has four 90-degree angles, but it's not a square because all of its sides are not equal length. It's a weird way of saying that, but I think that that's good enough. What about a non-square rhombus? Well, what you need to know about a rhombus is a shape that has all of its side lengths the exact same, but it's not a square. So let's see if I can find any of those. This kind of looks like one here. It looks like PGED. All sides are congruent, aka same lengths. But not 90-degree angles. Excuse me. Okay, what about a non-rectangle, non-rhombus parallelogram? Ugh. Okay, so now what I'm doing is I'm looking for something that has two sets of parallel sides. However, it's not a rectangle, so it doesn't have 90-degree angles, and it's not a rhombus, so all of its sides are not the same length. I think the easiest one for me to see is J, or maybe KJGD? Sure. It's a parallelogram because it has two sets. Whoa. Two sets of parallel lines or parallel sides. But it is not a rhombus because not all of its sides are equal length. And not all angles. It's a weird way of saying that. Not all angles measure 90 degrees. Something to that effect. Okay, cool. What about a kite? Well, I guess I gotta switch colors again here. Maybe I'll go back to blue. Let's see. The kite I see sitting up here. There might be others buried in here somewhere, but the one that jumps out to me is BNDC. There's other ways you could specify that as long as you list those four letters. Technically, you're supposed to go in a circle around this thing, so like CBND or CDNB. But I don't know, I'm not too picky on that kind of stuff. BNDC, that is this kite up here, and it's a kite because it has two sets of adjacent, where am I going to write this? Adjacent equal length sides. So that makes a kite. What about a non-isosceles trapezoid? Well, a trapezoid has exactly one pair of parallel sides. But to be non-isosceles, that means that the non-parallel sides are not equal length. So I think there's a few of those in here. One would be this thing right here, for example. So one possible example of a non-isosceles trapezoid. Let's see, let's go up here for this one. Would be, I don't know, KIGP. It's one of them. Lots of other ones. KIGP. Exactly one set of parallel sides. But it's not isosceles, so but other sides are not equal length. Good enough. What about an isosceles trapezoid? Well, I'm going to get a little redundant here because I kind of just described what that means. An isosceles trapezoid, let's see, here's one. I don't know if there's more, but KJGP would do the trick. Maybe I'll write this one here. KJGP. And kind of the same thing. Exactly one set or one pair of parallel lines. And other two sides are equal length. Okay, what about a scalene triangle? Bet I could figure that out. What color should this be? I don't know, maybe green again. So a scalene triangle, what a scalene triangle is a triangle that has all three sides having different lengths. This looks like a scalene triangle to me. DGF? DGF. I think there's a lot of different scalene triangles, but one of them would be scalene triangle DGF. All sides have different length. Okay, what about an isosceles triangle? An isosceles triangle, actually, I think an isosceles triangle has at least two sides of equal length. So maybe I should have said a non-equilateral isosceles triangle if I was being really picky. But for an isosceles triangle, I'm looking for a triangle in here that has two sides of equal length. Let's see, how about this guy up here? Well, that might be equilateral. How about this guy? That's pretty clearly not equilateral. How about NBC? NBC has two equal length sides. Triangle width. Fine. And what about an equilateral triangle? Well, an equilateral triangle is one with all three sides having equal length. I don't know, kind of hard to see, hard to measure them out, but PDG might do the trick right here. DGE might work. NCD, I think that one might work also. Hard to tell without having something to measure it. AKD sort of looks like it, as does AJE. Hard to tell. At any rate, I'm going to go with PDG because that's the first one that jumped out to me. But other answers are possible. PDG, 3 equal length sides. And maybe my note on all of these are other answers are possible. So just an FYI, don't freak out if you get answers different than these. Really, the explanations will help figure out if you found the same type thing. And then identify all acute, right, and obtuse triangles in the picture above. Why did I ask you to do that? That's going to be a pain. But all right, I guess I should do it. So let's make some lists. Here's the acute, here's the right, and here's the obtuse. An acute triangle is one where all three angles measure less than 90 degrees. A right triangle is one that has one angle that is 90 degrees. An obtuse triangle is a triangle with an angle that is greater than 90 degrees. So let's first look for acute. ABM would work. What else would work? AKD would work. Anything that's an equilateral triangle is going to work. AJE would work. Anything else that's acute in here? That looks like a right triangle. That looks like a right triangle. That looks like an obtuse triangle. Here's another one. NCD would work. No, I'm sure I'm going to miss some. This is a terrible problem. What about this guy right here? What about BND? That looks like a 90-degree angle to me, so I think I'm going to call that as a right triangle. What about BKD? Same thing. I think that's a right triangle there, so I'm going to go ahead and call that one right as well. This looks obtuse. Right, right. Right again, although the page kind of bending, it's hard to see. All right, let's head down here. There's a right triangle. Here is another acute triangle, PGD. And DGE. And to be perfectly honest, that's probably not all of them. Probably missing a couple somewhere in here. But I don't think that I want to do this any longer, so I am going to call that good. Did I get NCD? I think I got that one. Yeah, I did. Yeah, let's call that good. If you found more power to you. What about right triangles? Maybe I'll even write here. Maybe more that I missed. Okay. What about right triangles? Well, there are a ton of those. BNO, BCO. NOD and COD. What else do I have in here? How about KLM, KLB? And this one, I think that looks pretty right to me, so KBD. BCD. I think I got all the ones in here. Got that guy. Doesn't look like there's any more connecting that. I guess I'm moving on to down here. IJK. DGF and DEF. Maybe I call that good. Maybe I like offer extra credit for people that find the ones that I didn't find because I don't want to do this any longer. So I'm going to go ahead and stop there. What about obtuse? An obtuse triangle, as I mentioned earlier, is a triangle with an angle greater than 90 degrees. So for example, KMB would do the trick. Where else do I have weird looking triangles like that? NBC. Looks like that angle B is obtuse, or at least it looks obtuse to me. Maybe that's all of them. Or maybe that at least is enough that we've beaten this thing to death. And we can end the... Oh, I said that one. Yeah, okay, good enough. I'm going to end this here. Not the greatest, not the quiz I'm most proud of. But what are you going to do? First quiz, we'll call this good.